अस्सलाम वालेकुम। टुडे वी विल बी कवरिंग रिलैक्सेशन ऑसिलेटर्स। हमने इससे पहले कवर किया हार्मोनिक ऑसिलेटर्स एंड एज डिस्क्राइब्ड इन प्रीवियस वीडियोस। उसमें क्या था कि दे टुक अ साइनोसाइडल इनपुट, यस डीसी आप देते थे, एंड जो उनका आउटपुट वेव फॉर्म बनती थी दैट वाज साइनोसाइडल। ऑसिलेटर की डिस्क्रिप्शन हैज़ बीन डिस्कस्ड प्रीवियसली in which you have observed that there is no input waveform given to any oscillator, and just by giving the biasing DC voltages you generate a specific waveform. So relaxation oscillators actually work with any other waveform other than sinusoid. It can be sawtooth, triangular, square waves, etc. So we will be covering three of them, right? A triangular waveform can be generated with the help of this circuit, which is basically a integrator circuit. If you have covered an integrator circuit, which can be created with the help of a op amp and a capacitor in the feedback loop and a resistor, right? So all we have to add in addition to this is basically a switching circuit जो continuously पॉजिटिव एंड नेगेटिव वोल्टेजेस के बीच में स्विच करेगा. सो अ कांस्टेंट वैल्यू, लेट्स से इट्स 10 ऑफ मैग्नीट्यूड डीसी. व्हेन वी टेक एन इंटीग्रल ऑफ दैट वैल्यू वी obtain a value, let's say integral with respect to t अगर हम लेते हैं तो we obtain a value t. it means कि आपका लाइन आती है, right? with rising value of t there is a rising line curve, right? not a constant, right? So yahi concept somehow is applied to generate a triangular waveform. But before going into the details of integrator, if you want to observe ki how an integrator is generated, because I said कि आपका ये circuit use हुआ है as an integrator. So if you can observe, zero voltage is here, so same zero voltage is here. But in other words, you can also say that V output or VC is equal to 1 over C times IC, right? Or we can also say, because it's the same V output which is equal to VC, we can also say that VC is equal to, we know that VC is equal to 1 over C times the integral of IC. And here in this specific condition, your IC is V in by R. So if you place it in this specific equation, you know that this is the same current flowing through this loop, right? So when we place it, so VC is equal to V in by R, right? And when we just take out the C and R, 1 over time constant, so VC is equal to 1 over time constant type V in, right? Similarly, because VC is just flipped in direction to V out, so we can only place a minus sign, and it is equivalent to 1 over RC time V in, right? So when there's a continuously flipping square waveform in the input which we are trying to produce, so iska integral would be a square waveform, a triangular, right? A triangular waveform, and this is what we will be producing in our circuit. So another important aspect which we will be adding in this phenomena is comparator, right? So this flipping voltage will be produced with the help of a comparator, right? Which with the help of this comparator we will be actually generating this waveform. And finally, means आपका पहला block ये होगा, and then the next block would be of your integrator. Both are created with the help of op amp, right? So comparator क्या करता है कि there is a specified input voltage and we set a reference voltage, right? Now in our circuit, reference would be coming from your output, right? because we are closing the loop and we are feeding back the output to the input in the oscillations, right? Oscillator, right? So जब आपका V input greater होगी from V reference, then output is equal to positive VCC. And when your V input is less than V reference, then your output is equal to negative VCC, right? ये आपका flip करता है between two saturation voltages, positive VCC and negative VCC, right? And ये reference voltage आपके feedback से it will be fed to your negative feedback terminal, and positive पे whatever voltage is you will observe in the coming slide, right? So comparator में you can see that your output is dependent on the value of input voltage, which is V in is with respect to some DC voltage level, and as the output is high, when the voltage on the non-inverting input is greater than the voltage on the inverting input, right? As I said to you previously, this is the phenomena that would be observed, right? Similarly, जब आपकी voltage low होगी non-inverting input पे, in that case your then in that case आपको क्या हो जाएगी? It would be toward negative minus VCC, right? आपकी waveform should be towards minus VCC. Anyhow, plus एक और phenomena which is most common here, which is you can observe that practically आपकी जो DC biasing voltages हैं उनके ऊपर your dependence of your op amp is quite a lot on your DC biasing voltages. And generally some circuits use a resistive voltage divider circuit, right, to supply this input reference voltage of comparator, right? But sometimes a Zener diode or a potentiometer or a battery source can also be implemented, right? Anyhow, मैंने आपको दो circuits बताए हैं, comparator circuit and a integrator circuit. When we merge both of them, we actually generate this version of circuit which generates an output of triangular waveform. Here this scenario will be created with the help of a comparator circuit, and this scenario of creating the triangular waveform will be produced with the help of an integrator. So the final circuit would be somewhat like that, right? Now you can see this is your comparator and this is your integrator, right? Whatever is the output of comparator, if you can see, you are taking the final V output back and feeding with the help of a voltage divider, you are feeding it back to your positive terminal, right? Now this feeding back towards your positive terminal, this is creating the phenomena कि आप जब V reference is 0, right? Actually negative terminal is 0 and आपकी whenever this voltage would be greater than 0, क्या होगा? Your voltage would be positive. Similarly, when it would be less than 0, your voltage would be negative. And similarly, when with respect to your square waveform, आपकी flipping occur करेगी. Finally, when your this waveform यहाँ पे जो final comparator से निकल के आती है, when it passes through your integrator, right? Once again, when you are feeding your V output here, right? तो ये जो final यहाँ पे output voltage निकल के आएगी when your voltage applied here is less than your this voltage, which is 0. It will be 0 because आपने 0 apply किए. There's no input voltage which you are applying, so your reference is with a voltage. Your 0 voltage is you can say it's a reference with either a positive voltage or a negative voltage. So based on this reference, your output voltage would be a square waveform, right? And when you take the square waveform and feed it to an integrator, the final output waveform would be this triangular waveform. So this is how you will be creating your practical triangular wave oscillator, right? Let's move toward your other version of oscillator. Acha, yes, before going to the next version, let's cover the frequencies as well. You know that there are two values, right? This triangular waveform is divided into an upper trigger point and a lower trigger point, and upper trigger point is dependent upon V maximum and V voltage of lower trigger point is dependent upon your V negative V maximum, right? So these two can be calculated with the help of these two formulas. So upper triggering point voltage can be calculated with your positive, you know that you applied a voltage divider here, right? You know that it's a voltage divider, and this voltage which you are taking back as an input is actually the ratio of this voltage, right? So V output would be either V maximum plus or V maximum minus, right? So plus V maximum times the ratio of this voltages, right? So this is how you feed back your voltage and you describe your VTP, right? So it's the positive time R3 by R2, or it can be minus V maximum R3 by R2, right? So these two levels describe your final triangular waveform which is generated on the output, and you can calculate its amplitude with the help of these resistors, right? Similarly, you can also calculate the frequency with the help of this set of resistors and capacitors used, right? ये तीनों आपके and plus your capacitor calculates actually the frequency of your waveform, right? So your frequency is 104 times R1 C R2 by R3, right? So you can calculate it as well. Okay, let's cover the other two relaxation oscillators in the next part of the video.